In the second video of 9.6, we're going to continue where we left off with property of logarithms. This time though, what we're going to do is we're going to take this compacted logarithmic expression and we're going to expand this, writing it as sum or differences of logarithms. So what we're going to do is recall what our properties were. We have the product property, we have the quotient property, and we have the power property. So the first thing we're going to notice is that there is multiplication in here. Multiplication between the 6 and the 2. So that uses the product property, which we can break that apart using addition. So we're going to take that part and we're going to use the base log base 7 of 6. And then we're going to add it to log base 7 of 2. And that takes care of that top part, that multiplication. Next, we're going to look at right here is that division part, and what breaks that apart is that quotient property, which uses subtraction. So then we're going to minus log base 7 of 5. Number 11, the main thing that we're going to see right away is that it is going to have that division sign, log base 3 of x to the 4th divided by y to the 3rd. So that division right there can be broken apart using subtraction. So we're going to do log base 3 of x to the 4th minus log base 3 y to the 3rd. Now, the other thing though that we got to keep in mind is now that both of these have exponents, and that takes into account the power product or power property. So that 4 is going to go on the outside as a coefficient, and so it's 4 times log base 3 of x minus 3 times log base 3 of y. Another way that we can use these properties is to actually evaluate properties with expressions. So if we know values of different logarithms with the same base, we can break apart larger values or smaller, depending on if you're using the quotient or the product property, and we can actually find the exact value of it. In this case, we're given log base b of 4 equals 0.87, and log base b of 7 is equal to 1.21. And what we want to do is evaluate this. Now, we know if we look at number 12, log base b of 28, 28 can be broken down into 4 times 7, the numbers given above. So what happens here then is I'm going to use that product property to separate it, and it's going to be log base b of 4 plus log base b of 7. And then we're just going to substitute it in. Log base b of 4 is 0.87. Log base b of 7 is 1.21. When we add those together, we get we're going to get 2.08. In number 13, there's actually two ways we can approach this. We could use the product property and do 7 times 7. But another way to think about it is to use the power property, which is 7 squared. And then I can do 2 times log base b of 7, which evaluates to 1.21, and multiply that by 2, and you get 2.42. Number 14, we're again going to use that power property and change log base b of cube root of 4 to log base b of 4 to the 1/3. And I'm going to bring that 1/3 out, and we get 1/3 times log base b of 4. And so now I have 1/3 times 0.87, which equals 0.29. And the last thing I want to talk about in this video is just a couple of notes or things that we talked about in the other section kind of briefly that I want to emphasize in the last video. So remember that anything to log base b of 1 is equal to 0. Because if we did have log base b of 1 and it equals an unknown, or we're trying to evaluate, b to the x equals 1, if we write it as exponential, we need to know what that x is, and the only way to get 1 out of that is if x equals 0, because anything to the 0 power is 1. And these two kind of go hand in hand. If the base of an exponent has a log with the same base, then those are going to cancel out and just evaluate to x. And again, we saw this in the last video. And the reason why is if I kind of rearrange this a little bit to a logarithm, it's log base b of x equals log base b of x. So you'll see how those match up. And again, the same thing holds true over here. If the argument, the base of the argument right here, is the same as the base, that will cancel out, and whatever that exponent is, that will be the evaluated answer.